Okay, so to solve our momentum problems, we're going to use a system of momentum conservation diagrams. And what we have here is we've got velocity on the y-axis and mass on the horizontal axis. And so momentum becomes the area under the curve, right? That would be my momentum there. Okay, so let's get started and see how this works. First, we read the problem and we're saying, okay, we've got an empty boxcar. Let's call that the red one, moving at 3 meters per sec. The empty boxcar has a mass of 9,000 kilograms. And then let's take the other car, the loaded car, that is stationary. The loaded car has a mass of 55,000 kilograms. So we want to look then at what's our event. Our event is the collision, where they stick together. Okay? So now we need to find momentum of the system. So we go and look at our empty boxcar, has a mass of 9,000 kilograms. So let's just pick a number on here and let's call that's about 9,000 kilograms. Okay? It has a velocity of 3 meters per second. 3 meters per second. And then we can say here is the momentum of that car beforehand. Now let's look at the blue car. The blue car, 55,000, that's almost about 6 times bigger. So we're probably not going to be able to quite fit that here. But we're going to say there's 55,000 kilograms. It has no mass, so we don't add anything vertical to it. So momentum of the system is going to be our mass times velocity. So we have 27,000 kilograms times meters per second. Okay. So that's our entire momentum before. The system momentum then is 27,000 kg meters per second. Okay, we've got our initial conditions defined on the left. Now we're going to go over here on the right side. And now we've got the entire system now has a mass of 9 plus 55 is 64,000 kilograms. And the question is then, how fast is it going? So what do we know? We know that this area under the curve is still equal to the momentum of the system. So we can solve for that. We can come in here and we can say, okay, momentum, 27,000 kilograms times meters per second equals the mass times the velocity final. Plug that in the calculator really quick, and we get 0.42 meters per second is our velocity final. So basically all we're looking for here is what's my initial momentum area under the curve has to equal my final momentum area under the curve. So change in momentum of system 1. System 1 started with 27,000. How much did it end up with? Let's go, that's our red. So red is now going at 0.42 meters per second, and it's 9,000 kilograms. So plug that in your calculator. 3.78 thousand kilograms times meters per second squared. We started out with 27,000. So 27,000 minus 3.78 gives us the change is a negative. So it lost 23,000. How much did the other car gain? It should be the same. Let's make that in blue. And we can check that if we take our 0.42 meters per second times our 55,000 kilograms. That's 23.1. And because I rounded off in here, that's why we get a slight difference there. So if I kept more sig figs here, in here, I should have got the same answer. Okay, final step then is the vector diagram. So here we're going to say our momentum of the red car, it has a momentum of 27,000 kilograms times meters per second. And in the end, we end up with the red car now having, it lost 23,000. So it has 3,780, a short line. And the balance, this here, we've got 23,200. So we start with this total momentum here should equal this total momentum here. We're showing it as vectors. In some cases, you may have negative vectors going on. Okay, so that's about it.